Hello friends, in this video we'll discuss reflection, chapter 10, light reflection or refraction, and we are going to discuss this topic, reflection. We all are acquainted to see our face, to see the image of our face in a plane mirror in the early morning. This is a mirror. What happens in this mirror? Look at here. When light ray incident on it, then it bounces back, and this bouncing back of the light is known as reflection. As like when a ball is dropped on a surface on the floor, it bounces back. Similarly, when light ray incident on a plain polished surface, it also bounces back. This phenomenon is known as reflection. There are two types of reflection. One is regular reflection. Another is diffuse reflection. What is regular reflection? Suppose this is a plane mirror. In this plane mirror, this side is up. This is the reflecting surface. Let us consider a parallel beam of light is incident on it. Okay? Then what happens? It reflects back. The reflected beam is also parallel. Here I am using the word beam. Ray and beam. Ray is the single path of the light followed. Bunch of the rays. This is known as beam. As they are parallel, so this is a beam of light, parallel beam of light. Similarly, when in case of diffuse reflection, what happens? Suppose this is irregular surface. When the light ray incident, these are the parallel beam of light. Although they are parallel, but they reflect in different way. So this is diffuse reflection and this is regular reflection. In case of regular reflection, the image is formed. In case of diffuse reflection, the image doesn't form by that reflecting surface. You can take an example. We can see an object only when light ray incident on it and reflects to our eye. The image is formed in the eye, then only we can see it. That means in a sheet of paper, in our book, when we read the book, the reflection takes place as well as the reflection takes place in a plane mirror. We are able to see the image in a plane mirror, but we don't see the image in a paper, in a sheet of paper. The difference is the surface of the plane mirror is plane polished. That's where regular reflection takes place, where image is formed. And the surface of the sheet of paper is diffused, irregular. That's where the diffuse reflection takes place. We cannot see the image in that reflecting surface. Now, you can take another example. Let us take a bucket of water. You can see your own image. But if you shake it gently, then what will happen? The image will disappear. You cannot see your image. It is because of the diffuse reflection takes place when you shake the bucket of water and the surface became irregular. That's why it is also known as irregular reflection and diffuse reflection. Okay? Now, laws of reflection. Laws of reflection. There are two laws. First law is the incident ray, reflected ray, and the normal at the point of incidence or lie in same plane. Suppose this is a plane reflecting surface. This is incident ray, the incoming light ray, incident ray. This is the normal at the point of incidence. Normal means perpendicular. Then this is reflected ray. the incident ray, reflected ray and the normal at the point of incidence all lie in same plane. Okay, they lie in this case they lie in the plane of this seat, plane of this board. So this is first law. In another way, suppose a ball is thrown without any spin. What will happen? After bouncing back from the floor, it will move in that plane. Okay, if it is thrown without any spin, then after bouncing back from that floor, what will happen? From the surface, it will move in that plane only. So that means they lie in same plane. The incident, the reflected and the normal all lie in same plane. This is incident ray. This is reflected ray. This is normal. This angle, the angle between incident ray and the normal is known as angle of incidence. This angle between reflected ray and the normal is known as angle of reflection. So second law is the angle of incidence is equal to angle of reflection. The angle of incidence is equal to angle of reflection. So these are the two laws. Now question number 1. Look at here. I must clear that angle of incidence is the angle between incident ray and the normal. Similarly, angle of reflection is the angle between reflected ray and the normal. Question number 1. Identify angle of incidence and angle of reflection in these two figures. This is a plane polished surface. What is angle of incidence here? This is not the angle of incidence because this is not the normal. Remember, angle of incidence is the angle between normal and incident ray. So first of all, draw the normal. This is the normal. This is normal which makes 90 degree with this line. So as this is 60 degree, so this is 30 degree means angle of incidence is 60 degree. So in this figure, the angle of incidence is equal to 60 degree. Angle of reflection also 60 degree. In this case, the light ray incident normally, this is 90 degree. Although the light ray incident normally, for normal incident, here the angle of incidence is 0 degree. Why? Because itself is the normal. As it is the normal and the incident ray both coincide. The normal and the incident ray both coincide. This is the normal, this is the incident ray. So gradually, if the incident ray approaches this, look at here, in this case they coincide. In this figure, both normal and incident ray coincide. That's why the angle of incidence is 0 degree, angle of reflection is also 0 degree. So, as angle of reflection 0, that's why it retraces the same path. Just bounces back along the same path. So this is due to reflection. So is it clear? The first law is incident ray, reflected ray and the normal all lie in same plane. Second is angle of incidence is equal to angle of reflection. Now, formation of image in a plane mirror. Formation of image in a plane mirror. Suppose this is a plane mirror. Let the object is placed perpendicular to it. To complete the ray diagram, for the formation of image, we have to take at least 2 rays. Suppose, let us take a point object. Suppose this is a point object. It is better to take the point object. Let the light ray incident normally. Then what will happen? You know, it bounces back along the same path. Another light ray incident here. This is the normal. Now it bounces back. It reflects back. Now produce it. Look at here. this is one reflected and this is another reflected ray, they never meet. They are moving away from each other. They are diverging. Okay. So let us produce in backward direction. They appear to move from this point. They appear to move from this point. Okay. So here image is formed. As the light ray do not meet actual here, so this is a virtual image. What type of image is this? Virtual image. I must clear there are two types of images. One is real image, another virtual image. Real image can be taken on a screen. Virtual image cannot be taken on a screen. As like the image formed on the screen in cinema hall is real image. Virtual image, the image formed on a plane mirror is virtual image. It can be taken on a screen, it cannot be taken on a screen. Second thing, it formed only when the light ray actually intersect. And virtual image is formed when light ray appear to intersect. They do not meet actually. So real image and virtual image, so this is virtual image. To clarify this here, what happens? Dotted is, they are represented by dotted line. Means it is not the path followed by the light actually. That's why this is what? Virtual image. What are the other properties of the images? First is virtual and erect. Okay, it is virtual and erect. Second is it is the object distance. That means it is the image is behind the mirror as the object is in front of it. Image is behind the mirror as the object is in front of it. Third thing, that the lateral inversion takes place. Lateral inversion means the right hand side seems to be left hand side and the left hand side seems to be right hand side. Then the size of the object and image are equal. So there are four properties of the image formed by a plane mirror. First is it is virtual and erect. Second is it is same size of the object. Third is it is formed behind the mirror as the object is in front of it. That means the distance of the object from the mirror is equal to distance of the image from the mirror. And fourth one is lateral inversion. Okay. So this is the image formed by a plane mirror. You remember, any image which can be taken on a screen is known as real image. Okay. Here one question I must ask. It will be cleared in the chapter of human eye and the colorful eye. Human eye and the colorful one. That the image we can see the image only when it is formed in our retina. Okay. But the image formed in a plane mirror is virtual. So how we are able to see it? Although it is virtual, it cannot be taken on a screen. Remember, this question will be clarified in human eye and the colorful one. Now, so this is plane mirror. Now come to spherical mirrors. Spherical mirror. Spherical mirror, there are two types of spherical mirrors. One is convex mirror, another is concave mirror. Let it concave mirror, first one, and second one is convex mirror. Try to understand what are these. This is a concave mirror. You can see this is a concave mirror. This is a concave mirror and this is a convex mirror. There are two types of mirrors. Look at here. This is convex, this is concave. It is like this, concave. But it is just opposite. It is like this. Okay. This portion is bubble out, whereas this outer edge is, that means bubbled out, whereas it is what? At the lower height. So this is concave mirror and this is convex mirror. Okay. how these mirrors are formed. What is the difference between this one and this one? Look at here. Although it is made up of glass, but no, here light can easily pass through from one side to another side. If this side is coated with particular material, then what happens? The light reflects back, then it will convert it into a mirror. Okay, as like look at here, this side is reflecting and this side is coated with a particular substance, and due to this coatation it behaves like a mirror. So one is concave mirror, another is convex mirror. In this concave mirror, look at here, this side is reflecting surface, but this side is reflecting. Okay, so this is what? Silver. Now, how these mirrors are formed? You all are acquainted with this? Okay, it is let it is completely spherical. Although it is not completely spherical, let it is completely spherical. Open it. I have taken this portion only. Okay. That means this is a part of a sphere. This is the complete sphere. From this complete sphere, this part is taken. Now, if I silver this surface, if this surface is silver, then what will happen? This type of mirror is formed. Okay, and it will be a concave mirror. But if this side is silver, this type of mirror is formed. What is this? This is a convex mirror. That means concave and convex mirror are the part of a sphere from which they are taken. Now, so this is concave mirror and this is convex mirror. What are the different terms associated with this? This is taken from a sphere. This is also taken from a sphere. Now, the sphere at the center is known as center of curvature of this mirror. Center of curvature of a mirror is the center of the sphere of which the mirror is a part. The first one is center of curvature. Center of curvature. The center of curvature of a spherical mirror is the center of the sphere of which the mirror is a part. Similarly, in this case, this is center of curvature. Okay. Second one is the pole of the mirror. The center of this mirror, look at here, center of this mirror, the midpoint of this mirror is known as the pole. This is also known as pole. Try to understand. This is, let it is the sphere. The center of the sphere may be at this point, inside it. So this is a sphere of center of curvature. Whereas the center of this part of the center of this mirror is known as pole. You can see there is a small point. Please look at here. There is a small point here. This point is the pole of this mirror. Okay, this is pole of the mirror. Let us consider imaginary line. The line passing through the center of curvature and the pole. This is known as principal axis. Similarly, this is also principal axis. So what is principal axis? The line which passes through center of curvature and pole of a mirror is known as principal axis. Okay, for example, this is the, suppose this is a concave mirror, this point is pole, and this is what? Principal axis. This is what? Principal axis. Okay. If we take this plane, it must be perpendicular to this plane. Look at here. Okay. So this is principal axis. Now, next term is focus, represented by F. What is represented by? What is focus? Look at here. When a light ray parallel to the principal axis of a concave mirror incident on it, then it reflects back and meet the principal axis at a point. Let us take another light ray parallel to the principal axis. What happens? They all meet at a point. They all meet at a point. And this point is known as focus. So in case of a concave mirror, what is focus? Focus is the point where a parallel beam of light meet after reflection from this concave mirror. What happens in case of a convex mirror? When a beam of light incident don't forget to put the arrow mark. When a beam of light incident, what happens? They diverge. They move away from each other. They move away from each other. This is known as focus. I repeat. Focus is the when a parallel beam of light incident on a mirror and reflect back, either they meet at a point or they seem to diverge from a point. That point is known as focus. In case of a concave mirror, the parallel beam of light after reflecting from the mirror, they meet at a point, that is focus. And here they diverge from a point. This is known as the focus. Okay? Then radius of curvature. It is very simple. Radius of curvature R. It is the distance. Okay, it is PC. PC is the distance. It is the distance of separation between center of curvature and pole. Or in other way, it is the radius of the sphere of which the mirror is a part. Radius of the curvature. Then focal length. It is represented by small f. Focal length means the distance between P and F. This distance is known as what? Focal length. Focal length is the distance of separation between P and F. Pole and the principal focus. Here I use the term principal focus. The focus which lies on the principal axis. This is principal focus. Okay, or simply known as focus. Now, here they meet at a point. This is converging mirror. Here, the parallel beam of light move away from each other. That's why this is a diverging mirror. I repeat, this is a converging mirror because light ray meet at a point after reflection. This is a diverging mirror because the light ray diverge, move away from each other after the reflection. That's why this is known diverging mirror. In this mirror, actually the light ray meet at focus. That's why this is real focus, whereas this is virtual focus. So which mirror has real focus? This concave mirror has real focus and this convex mirror has virtual focus. Now, what is the radius of curvature of a plane mirror? This is a plane mirror. So what is the radius of curvature? इसमें तो sphere है ही नहीं. There is no sphere. No, there is a sphere. Plane mirror is part of a sphere of infinite radius. Imagine. We know that Earth is spherical, but when we see the surface of the Earth looks like a plane. It is because that we only see very small part of that sphere. That means if we take a very small part of the sphere, it will be like a plane. The same thing happens with a plane mirror. So it is part of a sphere of infinite radius. That's why its radius of curvature is infinite as well as focal length infinite. In case of a plane mirror, focal length infinity, the radius of curvature is also infinity. So let us verify this converging and the diverging in case of a plane mirror and a convex mirror, concave and convex mirror. Imagine this is a parallel beam of light. Imagine this is a parallel beam of light. Imagine, because parallel beam of light can be seen only when it is taken away from it. Imagine, okay, this is a beam of light. Try to observe the reflected beam. Try to observe. You can see the reflected beam of light are going to meet at a point. Look at here. This is the beam of light. They are going to meet at a point. Yes, they meet at that point. This is the focus of this concave mirror. This is a concave mirror. You can see this is a concave mirror. So they are going to meet at this point. So this point is focus. You can observe here. Look at here. How do they converge at a point? But after meeting the focus, they again diverge. They move away from each other. You can see clearly. Okay, they move away from each other. But after reflection from this concave mirror, they converge and they meet at a point. You can clearly observe. Okay. Now come to the behavior. Verify the behavior of what? Convex mirror. Look at here. After reflection, they diverge. The light ray diverges from each other. You can see these are the divergent beam of light. They diverge from each other. They diverge. You can see. So this is a diverging mirror. Okay. What happens in case of a plane mirror? They placed. Look at here. They neither diverge nor converge. They just return back along the same path. So this is plane mirror. Now, question is, why in case of concave mirror light ray parallel beam of light converge and in case of a convex mirror they diverge? To follow the laws of reflection. This is a concave mirror. Suppose this is pole, this is center of curvature. Focus is exactly at the midpoint of center of curvature and the pole, because radius of curvature is equal to twice f. What happens? Look at here. Suppose a light incident here. Now, this is the normal. You may study, or you might have studied in class 9 mathematics, that in case of a circle, the radius at the point of tangent is perpendicular to the tangent. So here if we draw a tangent, this is normal. Look at here. This is normal. This is incident ray. This is angle of incidence. So light ray will reflect back in this way such that the angle of incidence, angle of reflection are equal. Angle of incidence and angle of reflection are equal. So this is the normal. This is reflected ray. This is incident ray. To follow this, in case of concave mirror, the light ray meet at the focus. What happens in case of a convex mirror? This is a convex mirror. This is pole, center of curvature, pole, focus. Let us draw the normal. Similarly, this is the normal. This is angle of incidence. To follow the laws of reflection, it must reflect back. Okay, so this is focus. This is angle of reflection. Incident ray, reflected normal lie on same plane, and angle of incidence equal to angle of reflection. So remember, the laws of reflection are followed for all type of mirrors: plane mirror, spherical mirror, and convex mirror. Thank you.